decomposition. So this is another technique of integration. Let us consider an integral of the form integral of n of x over d of x dx where the integrand n of x over d of x is a proper rational function So when we say n of x over d of x is a proper rational function, the degree of the numerator, which is a polynomial, is less than the degree of the polynomial d of x. Is that clear, guys? So again, the degree of the polynomial n of x is less than the degree of the denominator d of x. By integration by the method of partial fractions, we're going to have 4 cases to consider. Depending on the factors of the denominator. Case 1, So for case 1, we have distinct linear factors as factors of d of x. In case you have questions, you can raise your hand or interrupt me. Don't hesitate. So this is the rule. If you have this case, distinct linear factors, for every distinct linear factor, of the form ax plus bx, ax plus b, that you can find in d of x, there corresponds a partial fraction of the form a over ax plus b. Okay, guys? So every partial fraction that you can have as a decomposition of n of x over d of x will have this form if n of x over d of x has a denominator distinct linear factors, meaning under case 1. So here, the constant a, the arbitrary constant a, is to be determined. Okay, guys? Actually, this topic is under under advanced algebra, partial fraction decomposition. Let us consider the following examples. Number 1, let's say we're given this integral of x plus 2, x plus 21 quantity dx over x minus 3 x plus 5. This is considered rational function proper, x plus 21 over all over x minus 3, x plus 5. So this integrand is a proper rational function. Why? The numerator is a polynomial of degree 1. The denominator is a polynomial of degree 2. If you're going to expand this, you will get x squared minus 3x plus 5x minus 15. So the highest exponent is 2. So the degree of the denominator is 2. Since the degree of the numerator is less than the degree of the denominator, so it is a proper rational function. Looking at the denominator, it so happens that the factors are both linear factors. So this is under case 1. So this integrand, we can split that in the form of two fractions, a over ax plus b, and another of that form. No? So let's have, so by partial fraction decomposition, we have x plus 2, 21 rather, over all over x minus 3. Arrangement, by the way, of factors in the denominator does not matter. You can have any arrangement. So again, x plus 21 all over x minus 3, x plus 5. So you will have, corresponding to these two factors, are two partial fractions. The first one, we have a over x minus 3. I will have another form like this, but instead of using a, I can use another name for the arbitrary. So let's say b over the second factor in the denominator. Okay, so you have two partial fractions, a over x minus 3 and b over x plus 5. We are going to determine this arbitrary constants a and b. So what are a and b? So that if I'm going to combine these fractions on the right side, will give me this left side. Okay. So the technique is to assign a value to x that will make the denominator 0. You might ask why assigning value that will make the denominator 0. That's just a technique so that we can easily determine a and b. Okay, guys? So I have a is equal to, for what value of x will this be 0 when x is 3? And then I'm going to evaluate this left side when x is 3, removing x minus 3. The factor that is what? That will become 0, no? When x is 3, I'm going to remove that. So we now have x plus 21 over x plus 5. I remove what? I remove x minus 3. Is that clear, guys? So x plus 21 all over x plus 5. So this is now defined when x is equal to 3. So this will give me the value of a, the desired value of a. Okay? So it's a technique. We call this Herbicide Rule. So we have here 3 plus 1. So that's my x. So then plus 1 all over x. What is my x? 3. Then plus 5. Okay, guys? This is 21. Why is it that I always forget the constant? This is 21. You know, you're not correcting me, guys. Because when I was watching some videos, I see some corrections. So meaning you're not really listening. This is 21. So 24 over 8, this is what? Guys, 24 over 8, That is 3, na? What about B? For the value of B, this time, value of x that will make the denominator of b over x minus x plus 5, 0, no? So, for what value? When x is negative 5. So, when x is negative 5, this will be 0. And I am going to remove that factor on the left side and evaluate it when x is negative 5. So we have x plus 21 all over x minus 3 evaluated when x is equal to negative 5. Okay, guys? So this is equal to negative 5 plus 21 all over negative 5 minus 3. So we have negative 8 in the denominator. In the numerator, we have 16, and this is negative 2. Okay, guys? So we now have values for A and B. So I can now go back to my integral. So the integral now becomes integral of. So this sum, I'm going to have this now as my integrand. So we have the integral of the first term. So we have A. What is my A, guys? 3 over x plus x, x minus 3, no? Am I right? This one, integral of this, dx. So we get this integral. The second integral, we have minus, this is negative 2. So we have plus integral of negative 2 or minus 2, no? Over x plus 5 dx. Okay, guys? So this is equal to, I'm going to put 3 out of the integral sign. Then we have integral of dx over x plus minus 3. Dx over x minus 3 minus 2 integral of dx over x plus 5. So each integral leads to integral of du over u. So if this is my u, x minus 3, what is my du? Dx. So integral of dx over x minus 3 is equal to ln of absolute value of x minus 3. So similar here, no? So this is my du, this is my u, du over u. So what is the integral? Ln of absolute value of x plus 5. And of course, we multiply it by negative 2, no? So plus c. So this is the answer. Or if you want, you can express this in compact form. 1 ln, ln of, this becomes exponent of x minus 3, no? So x minus 3 quantity cubed over x plus 5 quantity squared. Then take the absolute value of this fraction. Okay? Plus c. You can have this expanded form or this compact form. Is that clear, guys? The absolute value, you can have it just in the numerator if you want. Because x plus 5 quantity squared is never what? Negative, no? Is this clear, guys?
Yes po, sir.
Okay, so let's have number 2. I do not know if you were able to discuss partial fractions, decomposition in algebra or in advanced algebra. So let's say we're given this integral of 7x cubed, I squared only. Squared, then plus 17x minus 4 quantity dx all over two x cubed plus 3x squared minus 2x. Let's check if the integrand is really a rational function. What's the degree of the numerator? 2. What's the degree of the denominator? 3. So it means it is a proper rational function. Okay, guys? Polynomial over polynomial rational function. The degree of the numerator is 2, which is less than 3, the degree of the denominator. So we're going to try to express the denominator in factored form so that we will know if it is under case 1, meaning the factors are distinct linear. 2x cubed plus 3x squared. So we have 2x cubed plus 3x squared minus 2x. This is equal to, factoring out x, we get 2x squared plus 3x minus 2. Again, 2x cubed plus 3x squared minus 2x. I can factor out x to get this other factor. This quadratic factor, I think, can still be factored na in the form of x plus 2, x minus 1 times 2x, no? Times 2x minus 1. Could you please check if I'm correct, guys? 2x squared, 4x minus x, so plus 3x minus 2. Okay, so that is the factored form of the denominator. Looking at the factors, they are all distinct linear factors. So this is really under case 1. Clear, guys? So we can now have the decomposition of this integrand. So by partial fraction decomposition, we have 7x squared plus 17x minus 4 all over the denominator in factored form is x plus 2, 2x minus 1. So for each linear factor, there is a corresponding partial fraction. So of the form a over ax plus b, no? So it so happens that my 2x, my ax plus b here is simply x. Plus another, so let's have b. So x plus 2 in the denominator. And the third partial fraction corresponding to 2x minus 1, we have c over 2x minus 1. Okay, guys? We now get this integral. I mean, the values of a, b, and c. A is equal to the value of this left side when x is 0. But of course, we have to remove this x, no? Removing the x, that makes it 0. So 7 times, what's the value here? 0, no? We assign 0. Quantity squared, 7 times 0 squared, plus 17 times 0, then minus 4, all over the value of these two factors, removing x. So we have 0 plus 2 times 2 times 0, 0 minus 1. So that's the technique of determining values of ABC if you have case 1. So for A, so we have negative 4 over 2 times negative 1. So that is negative 2. So the value of A is positive 2. Okay, guys? Guys? So what about letter B? So this is 0 for what value of x, guys? Negative 2, no? So we are going to remove x plus 2, the factor that is getting into 0, no? So 7 times negative 2 plus, that is quantity squared, plus 17 times negative 2 minus 4 all over what is x? Negative 2. And then 2x minus 1 is negative 4 minus 1. So when x is negative 2, we have 2 times negative 2 minus 1. So negative 4 minus 1. I removed x plus 2, the factor that makes the denominator 0 when x is negative 2. So simplifying, we get what, guys? Guys, what's the value? Guys, this is negative 10. Am I correct? I use calculator. 7 times 4, 28 minus 4, that is 24. Then 24 plus negative 34, negative 10 over, this is positive 10. The value is negative 1. So what about C? So this is 0, this denominator when x is 1/2. Is that right, guys? So
Yes po, sir.
7 times 1/2, quantity squared, and then plus 17 times 1/2, then minus 4 all over we have 1/2, that's the value of x, times, so I'm going to remove 2x minus 1, no? This is the one that is going to be 0 if x is what? Is 1/2. So x plus 2 is 1/2 plus 2. Let's use calculator. So 7 times 1/4 plus 17 times 1/2 minus 4. I got 25 over 4. Could you please check, guys? In the denominator, this is 5 halves. No? 0.5 times 2 is 2.5. That is 5 halves times 1/2, 5 to the 5 over 4. And this is equal to 5. Okay, guys? We now have values of A, B, and C respectively. So 2, negative 1, 5 respectively. So we now have this integral. So I'm going to put the values of arbitrary constants outside the integral and then integrate this, no? 1 over x dx, 1 over x plus 2 dx, 1 over 2x minus 1 quantity then dx. Okay, guys? So let's have the integrals of those. So the first value is 2, no? 2 integral of dx over x. The second integral, we have plus -1. So -1, I'm not going to write that anymore. Integral of dx over x minus 3. And then the last integral, we have plus 5 integral of dx over 2x minus 1. What's the integral of the first term? What is this integral? 2 ln of x, okay? Minus 2 ln of x minus 3. Because this is simply d over u, d over u. The integral is ln of x for the first, abs of that, ln of x minus 3. What about in the last integral? If 2x minus 1 is my du, what is the my u? What is du? 2 dx. So I need to put 2 balanced by 1/2, no, guys? So I'm going to put 2 balanced by 1/2 here. So giving what, guys? Do
5
I have
over
to
2, sir.
write that? So I'm going to put 1/2 outside, then 2 here, no? So that this now becomes d over u. So what's the integral? Two ln of x abs of x minus 3 plus 5 over 2 ln of abs of 2x minus 1. Oh, that's it. Plus c. Okay, guys? By the way, I changed it to c1 because I use c. The c in the partial fraction here, in this partial fraction, the c here has nothing to do with the c in the integral, okay? So I am going to change to c1 to distinguish the arbitrary in the partial fraction and the arbitrary in the integral. Is that clear, guys? You can use any letter you want that to represent in constant of integration. As long as not c, no? Because we used that already in the partial fraction. Okay, guys? Guys?
Yes po, sir.
Yes po, sir.
Okay, number 3. So we have integral of, so this is the last for this case, 2x cubed minus x squared. We have 4 cases under this technique. Plus, wait a minute. Minus 20, minus 26. Plus 19. All over x squared plus x minus 12. So quantity dx. Okay, guys, what can you say about the integrand, guys? Is it a rational function? Yes, no? But is it proper? Guys, Gonzales, is it proper? Guys. Domingo.
No po.
Secretario. Oh, is it proper or not?
Hindi po.
Not. So if it is not proper, so the first step is to carry out long division. No? So let's perform long division first so that the numerator will have what? Will have a degree less than that of the denominator. Okay, guys? But there will be, of course, a, a sum or perhaps a sum of terms na will not have a denominator of this anymore, no? So para bang if you have 5 over 4, you're going to change it to mixed number 1 plus 1/4, no? Or 1 and 1/4. Okay, guys? So let's do that. Ano bang mag-long division? So let's do that in Scratch here. We'll have 2x cubed. Let's begin with the denominator. X squared plus x minus 12. So this is the one that is outside. So the dividend is 2x cubed minus x squared minus 26x plus 19. So dividing, we have 2x cubed divided by x squared, that is 2x. 2x times x squared, we get 2x cubed plus 2x squared, then minus 12x times 2. So it is 24 minus 24x. Get the difference. 0, negative minus, negative 1 minus 2, negative 3. The literal part is x squared. Negative 26 minus negative 24, that is negative 2x. Difference, ha? Am I correct, guys, with my difference? Negative 1 minus 3 is negative 3, negative 26 minus, so it is negative 26 plus 24. So negative 2, literal is x. Okay? Let's bring down 19 plus 19. So negative 3x squared divided by x squared, negative 1. Negative 3. 3 times each term here, negative 3x squared minus 3x plus 36. Get the difference? We have negative, negative, so same na 0. So negative 2 minus negative 3, positive 1. Literal part is x. 19 minus 36 is negative 17. Am I correct, guys? Guys? So by partial fractions, we have ang atin lang ipapartial yung what we call this proper rational function part, no? So copy this quotient. So we have x minus 17 all over, what's the denominator? X squared plus x minus 12. But this is factorable into what? Guys, what is this, guys? That is x plus what? X minus 3, x plus 4. Am I correct, guys? So this can be split into two partial fractions, no, of the form a over x minus 3. The second one is b over x plus 4. So again, To solve for A, we have when x is 3. So 3 minus 17 all over. So we have to remove x minus 3. So getting only x plus 4. But when x is 3, we have 3 plus 4. The denominator is 7. Numerator is what? Negative 14. So that is equal to negative 2. What about B? B is equal to when x is what? Negative 4. Negative 4 minus 17 all over. So this is the factor that I'm going to remove. X plus 4, retaining x minus 3. That is negative 4 minus 3. So getting denominator is negative 7. Numerator is negative 21. So getting positive 3. A question, guys. So getting these integrals, so we have negative 2 integral of, that is my 8. I put it out. So what is my integrand now here? 1 over x minus 3, then multiply by dx, no? So x minus 3. Then plus 3. So this is my b. Integral of dx over x plus 4. Oh, now very easy now. Negative 2 d over u, integral of this. So we have ln of abs of x minus 3 plus 3 times ln of abs of x plus 4. Then plus c. No? I can use c now because I did not use c in the arbitrary constants in this partial fraction. A question, guys? Guys.
Wala po, sir.
Okay, so that's it. We call this case 1. Okay? What about if I have this? Let us have this. Let us have one more. After all, almost time, no? Let's see if we can have it in 10 minutes. Integral of 2 multiplied by 14 x cubed, then plus 2x squared minus 69x minus 72. I think there are softwares capable of splitting the given rational function in terms of its equivalent. By the way, I missed something. I think I got a mistake here. I missed what? Anong na-miss ko rito? Hindi ko na-integrate yung 2x minus 3. Sorry. Let's go back with that. Guys. I need 2 terms more, no? We have this part, guys. I forgot to include this. This part, no? Remember, this is the quotient. So I have to include that in the integration, no? So we have integral of 2x minus 1, 1 tt dx. Am I clear, guys? Oh, guys, kita nyo? You have no help. You did not warn me about that. So I forgot including such. What is the integral of the first term in this integral? 2x squared over 2, simple power. So that is x squared. Okay? minus, what is the integral of 1 dx? Minus x. Am I right, guys? Guys, may 3 pa ba? Ano ba yan? Ay, sorry, 2. This is 3. Ayan na naman, oh. Hindi ko na nakita. Labo na ng mata ko talaga. So, this is 3x. Let me totally erase. X squared minus 3x. Ayan, I think no more correction. Okay, guys? Guys? Wala, ayaw talaga. Tumagot na. 3x squared plus 4x times x squared minus 9. So these are the factors in the denominator. But let's see if these two factors in the denominator can each be factored into linear factors. Let's see. So this denominator can be written x, then 3x plus 4, x squared minus 9 is x plus 3, x minus 3. So every factor is linear. So this is case what? Case 1. So I'm going to split this rational function, this proper rational function into what, guys? So we have 2 times 14 x cubed plus 2x squared minus 69x minus 72 all over, what are the factors in the denominator? X, 3x plus 4, x plus 3, x minus 3. Yan. Okay, guys? And this is equal to a over x plus b over 3x plus 4 plus c over x plus 3, and finally d over x minus 3. So that is the corresponding partial fractions to this left side. By the way, the degree is 3 in the numerator, the degree is 4 in the denominator. So this is a proper rational function. Okay, guys? So first we solve for the value of a. A is equal to, when x is what? When x is 0, so we remove this factor x in the denominator, replace every x by 0. 0, 0, 0. So I will just have 2 times negative 72. So that is negative 144 over. So 3 times 0 is 0 plus 4, so 4. So this is 0 plus 3, so 3. 0 negative minus 3, negative 3. So again, I removed x, ha? So 4 times 3 times negative 3, so that is negative 36. Am I correct, guys?
Apo.
Negative 36. Okay. So we have negative 36. What's the value now, guys? Guys. 4,
4,
no?
sir.
Okay, 4. What about maybe? When x is negative 4/3. So equate this to 0. we get 3x plus 4 equals 0, x is negative 4/3. So that's what we are going to assign to x on the left side, but removing 3x plus 4 in the denominator. Okay, guys? Let me copy this because I can't remember this thing. What temporarily here. What's the value? Could you do it mentally? I mean, using your calculator, guys. So 2 times 14 times negative 4/3 quantity cubed plus 2 times negative 4/3 quantity squared minus 69 times, I'm looking at this, times negative 4/3 and then minus 72. Oh, what's the value, guys? Could you please check? I get 520 over 27. So again, let me check from my calculator. I multiplied by 2 outside after substituting 4/3 here times 2 the result. 40 times negative. What's my other calculator? Wait a minute. Easier here in my other part. 14 times negative 3 divided by 4 or 4 divided by 3. What is again our x? Sorry, negative 4 over 3. Negative 4 over 3, no? 14 times negative 4 over 3 quantity cubed. Then, plus 2 times 16 divided by 9, no? So that is quantity squared. Then, plus 69 times 4 divided by 3. Then, minus 72. But don't forget to multiply by 2. Okay, guys? So, I get here 520 over 27 negative. Or am I wrong? Could you please check, guys? Parang mali yung na-compute ko. Iba yung lumabas. 14 times negative 4 divided by 3 quantity cubed times 14. Hi guys, could you please help me finding the value? Plus 16 over 9, that is 32 over 9. Then magiging plus 69 times 4 over 3 plus na, no? 4 over 3. Then minus 72. Hopefully, I will get now the correct answer. Times 2. I get another value. Ay, what's happening to the calculator? Guys, can you get the value of the numerator? Guys?
Wait lang po, sir.
Sir, tinatry pa po, sir. Wait lang po.
Parang iba yung nakukuha ko eh. Because I don't have answers. But don't forget to multiply by 2, the outside one, because we have times 2 here. 14. Diretso ko na lahat. 14 times, ano ba yan? Times Negative na yan eh. Negative 4 divided by 3 equals times 16 divided by 9 plus 2 times 16 divided by 9 plus 69 times 4 divided by 3 minus 72 times 2. And then divided by the denominator. Ang aalisin ko itong 3x plus 4, no? Divided by negative 4 divided by 3 times we have negative 4 divided by 3 plus 3 times negative 4 divided by 3 minus 3. So,
Tama lang
I
po,
get
sir.
negative 2. I get negative 2 as the final answer. Tama ba yung numerator ko?
Opo, sir. Tama po.
Tama po,
Yung
sir.
60 ang
Yes, sir.
denominator eh. Kasi iba-iba lumalabas sa calculus. Ewan ko ba, ba't ganyan? Yan. Pero pag dinerecho, negative 2. So, it's correct now. What about letter C? Ito. Wala ng fractions. For letter C, it's already time. May klase kayo, guys. After this, tapusin
Yes,
lang
po,
natin.
Meron
Okay.
po, sir.
You may now leave. I will just be finishing para yung recording finished. Okay, guys? You may leave if you want. But don't forget to have the attendance. Then I will try to compute so that the recording is complete. So I get negative 40 or 50 over negative 90. And this is equal to negative 4. 5, sorry. 5. And then finally D, I get, so when X is 3 this time, kanina negative 3. So, substitute, but removing this time X minus 3. So we now have, I get 234 over 234. So this is equal to 1. Hopefully that's correct. 2 times 14 times 27 plus 2 times 9 minus 69 times 3 and then minus 72 enclosed equals 234. In the denominator, 3 times 9 plus 4 times 6. 234 also. Okay, 1. So the integral now is given by the following sum of integrals. For integral of dx over x minus 2, so meaning plus negative 2, integral of dx over 3x. Yan. I'll be providing space because I'm going to multiply something later. Dx over 3x plus 4 and then plus 5 integral of dx over x plus 3 and then finally we have plus 1 integral of dx over x minus 3. Okay, so I will put here 3 balanced by 1/3 so that this becomes du over u. So getting 4 ln of, you may go now guys minus 2/3 ln of 3x plus 4, abs of this, no? Abs here also, plus 5 times ln of abs of x plus 3, du over u again, integral of du over u, plus ln of abs of x minus 3 plus c sub 1. let me just use k plus k, may arbitrary constant of integral, because I use c here. Okay, guys? So, that's it. If you don't have questions anymore, or okay, you may go now, guys, if you want to. So we're now done. So we'll continue next meeting for the rest of the cases.